Hello, I'm recording today a new PhD thesis with a new scientific breakthrough in geology, and this thesis was done by Dr. Hamza Allafi, graduate from Newcastle University, and the title of the PhD thesis was, or dissertation, sorry, its integration of biostratigraphy, chemostratigraphy, and sequence stratigraphy for the study of the Miocene carbonate evaporite rocks in the Cyrenaica northeast Libya, which is basically East Libya. This thesis shows a breakthrough in the multidisciplinary study when he integrated biostratigraphy, basically foraminifera, with geochemistry, XRF elements, and stable isotopes, with sedimentology and sequence stratigraphy. And he came up with three major events in the Miocene: early Miocene, middle Miocene, and late Miocene. And let's go through the very interesting study. So by subject, Newcastle University is in the top 100 schools in geology. So here's the subject. This is the curve on the left here. This represents the occurrence of the counts, basically, of the foraminifera under thin section. He studied them, and the scale goes from 0 to 200. And this second curve is a sulfur element that measured by XRF. And the third curve here is carbon stable isotope. And the fourth curve, the blue one here, is oxygen stable isotope. And these two curves, the occurrence number of the fossils, or the counts of the fossils, and the sulfur, these new curves added by this study to compare with the previous studies done by Dr. Khalid Amri, Texas A&M 2015 in his PhD, and these two in the PhD of Dr. Hamza. But let's see here, look at this curve, first curve. So we find forams at the lower part where there's letter A. We see some spikes here, and then zero declination of the forams completely in the early Miocene, and then coming back, and then explosion, increase in the number, diversity, size of the foraminifera in the middle Miocene, and then again declination and some spikes in the late Miocene. When Dr. Hamza integrated this curve foraminifera occurrence and counts with the sulfur curve, with the carbon stable isotope and oxygen stable isotope, he did find that the time when there's declination of forams, there's increase in sulfur element, which is basically the main element in the gypsum, which is gypsum is calcium sulfate, hydrous calcium sulfate. And also this increase in sulfur accompanied by increase in oxygen stable isotope. That means there is a big event of evaporation or closure. When we look at this map here, during the Miocene, we find the Paleotaethys, which is the equatorial ocean, because was going from east to west, warm and nice. We find Gate A that closed during early Miocene due to the collision of the Arabian Peninsula with the Anadolu Peninsula, as we see today here. This collision caused the closure of Gate A in the Paleotaethys. And that confirmed in Cyrenaica, in the Miocene of Cyrenaica carbonate platform. So fossils very sensitive forams and recorded that event. Declination of fossil, increase in sulfur, increase in oxygen. When we go to the middle Miocene, which is denoted by letter B, we find explosion, increase in the fossil size, diversity, and numbers. And this accompanied by increase in carbon, stable isotope. And this is and this event coincides with the global transgression due to the ice melt during the Miocene, where we got a lot of nutrient material that led to the increase of the fossil size, diversity, and numbers. And then the last one is event C, which is the late Miocene event. We find like drastic declination and decrease in fossils, but we have some spikes of fossils forams accompanied with some increase in sulfur, but the stable isotope carbon and oxygen, they show declination. And if you look at the map here, which is gate C, which is between Africa and Europe, during that time, the collision between Africa and Europe happened and led to the closure of Gibraltar and basically the evaporation and the Miocene event in the Mediterranean. And the declination of carbon and oxygen happened when this collision happened between Africa and Europe, and uplifting of Africa in getting a lot of chemical weathering, like intense weathering happened that led to the declination of or decrease in carbon and oxygen, intense chemical weathering. Besides that, there's evaporation that led to the declinations of the fossils. This study this study showed that forams recorded three major events, like a collision in the East Mediterranean, and the closure of the East Mediterranean led to the declination of fossils, no replenishment from the eastern side. And then in the middle Miocene, there was global transgression, led to a lot of nutrient material, an increase of the fossil size, diversity, and number, accompanied by increasing carbon. And the late Miocene, which is C here, denoted by C, shows declination of fossils and the closure of the West Mediterranean, Gibraltar in Africa, and declination of carbon and oxygen due to intense weathering. This is a study done on 503 thin sections along in Cyrenaica state. Along the section is about 140 kilometers, and here from south to north. And as you see, the lithologies here starts with the blue color, which is at the bottom here, is bioclastics. The beige color is green, is red algae. And then the yellow color here represent oolitic greenstone, and then the red color represent evaporites, and then this orange color represent stromatolites. So the sequence showing progressive shallowing upward. That's this the cross section or stratigraphic cross section of the Cyrenaica. Great findings, multidisciplinary study. It shows, you know, a lot of results that will lead to like a more understanding, will lead to more understanding of the history of the Mediterranean over time. Miocene was a very interesting time, closure time, and the ocean changed, like from the Paleotatus was going east-west, equatorial warm, and then we got two closures at the east and at the west during early and late Miocene, and that led to the influence, like stopping the east-west equatorial flow, the warm flow, and we get influence from the Atlantic Ocean, the cold water, to interfere and replenish the water in the Mediterranean Sea. Thank you, Dr. Hamza Allafi, for your hard work and for your findings. It's very, very like interesting findings. And this PhD was done like uh, August 18th, 2026. It was Tuesday, so it was like 8 days old. All the best. Thank you very much for your work.